I want you to step away from your current environment, wherever you are, and just for a moment, visualize the Amazon rainforest.
Hmm.
And we're not talking about a postcard image here. We're talking deep reality. The Omagua, the lowland jungle, it's massive, dense, humid. You can almost feel the air vibrating with life.
Right.
Now picture a river running through the middle of that dense green tapestry. You'd expect it to be cool, right? Maybe murky brown, providing life and refreshment.
But this one does the exact opposite. I mean, if any animal were to fall into this river, the water wouldn't just be uncomfortable or scalding.
No.
It'd be instantly lethal. We're talking about water temperatures that get over 90 degrees Celsius.
90 Celsius, that's almost boiling.
It's high enough to cause immediate third-degree burns. High enough, frankly, to literally cook the muscles of any living thing that spends more than a few seconds in it.
It sounds like pure, terrifying fiction, something, concocted for an adventure novel or some kind of spiritual warning. But it's real.
It is very real.
This is the Shane Tempishka, the boiling river of the Amazon, located in the Huánuco region of Peru. The intensity is just astonishing. Andres Russo, the geoscientist who dedicated years to this, he described standing near it as being trapped in a sauna inside a toaster oven.
Yeah, that's a great description. That heat is palpable, it's pervasive, and it is absolutely deadly. And that sustained heat introduces this massive paradox that's going to drive our entire deep dive today.
Right, the location.
Exactly. Geographically, the Shane Tempishka flows in the foothills of the Andes, but crucially, it's hundreds of kilometers away from the nearest active volcano.
How far are we talking?
About 700 kilometers. It's inside what's known as the Peruvian volcanic gap.
700 kilometers. That distance is key, isn't it? Because if you've ever learned anything about geothermal features, geysers, hot springs.
They're always linked to volcanoes.
Always. You expect a shallow magma chamber, the Earth's heat engine right there, just under the surface. But here, the engine seems to be missing. It just defies all standard geological expectations.
Precisely. And that lack of a visible, immediate volcanic heat source is the central mystery we're here to solve. So the core question for you, listening right now, is this. How can an entire river flowing for over 6 kilometers run nearly boiling hot without any of the usual volcanic activity powering it? The physics, on the surface, they just don't add up.
So that's our mission today. We are going on a complete journey through this anomaly. We're going to start with the local legends, the spiritual beliefs that have defined this river for centuries.
Then we'll pivot into the science, the surprising, really elegant, and almost unbelievable explanation for how the Earth's plumbing created this marvel.
And finally, we have to confront the very real, very urgent conservation fight to protect this unique place from us, from human threats. It's a story where ancient myth, hard science, and the immediate need for survival all crash together.
To even begin to appreciate this river, you have to start where the local communities did, with wonder, with respect, and with a really deep tradition.
Yeah, for the indigenous Ashaninka and Shipibo communities who live there, the Shane Tempishka isn't some geological curiosity. It's a profound, sacred, living entity. They've known about it and used it for generations.
It's been a site for significant healing traditions. It's a spiritual anchor in their landscape. And the name itself, Shane Tempishka, it carries that spiritual weight.
What does it translate to?
It's from Quechua, and it's often understood as meaning boiled with the heat of the sun.
Wow.
That phrase is beautiful, isn't it? It suggests an origin tied to the sky, to celestial forces or powerful spirits, not just mundane physics underground. It's a poetic view that makes perfect sense when you're faced with a natural phenomenon that seems to break all the rules.
And the most powerful local legend, the one that really defines its spiritual essence, is the story of Yakumama.
Yakumama. That translates directly to the Mother of the Waters.
The Mother of the Waters.
Yeah. This figure is imagined as a gigantic, powerful serpent spirit, a protector and a shaper of the Amazonian landscape. And the local beliefs, especially those passed down by shamans, they assert that the river boils because of Yakuma's powerful presence, or maybe even her fiery breath deep beneath the earth.
So it's like the Amazonian equivalent of a dragon, but the spirit of the water itself, its presence is both terrifying and sacred. The boiling water, in some stories, comes right from her mouth.
Or from other powerful beings in the underworld, constantly feeding the river with heat. And that's fascinating, right? This highly dangerous natural force is woven into the community's spiritual fabric. It's tied to healing rituals and tradition, not just avoided as a place of death.
They live with it. They have rules based on generations of knowledge.
Exactly.
Now, let's contrast that ancient spiritual framework with the modern Western scientific view. Andres Russo, the geoscientist we mentioned, he first heard about it in a much darker way, through the conquistador legend.
Right. He's just a kid in Lima, and his grandfather told him this family's story. It's rooted in the history of the Spanish conquest,
The search for El Dorado.
the search for El Dorado. Spanish conquistadors pushing deep into the unknown Amazon. And the legend says that these soldiers, in their hunt for gold, stumbled upon a river of boiling death.
A river of boiling death.
A phenomenon so fierce it burned men and horses alive, driving them back from the jungle's heart.
It's a classic story of the jungle defending itself. So Russo carried that image with him all the way into his academic career. And as he's pursuing his PhD in geothermal science, he starts asking his colleagues this hypothetical question.
Right, he'd ask, could a continuously boiling river actually exist outside of a volcanic zone?
And what did they say?
The answer was pretty much a universal and immediate no. They all cited the known physics. Russo himself said his peers, understandably, just saw the idea as geologically impossible.
Because you need that massive, consistent heat.
You do. Without shallow magma, which shouldn't exist 700 kilometers from the nearest fault boundary, how could water flow hot for miles? The energy required to heat that much water continuously is it's colossal.
They were all working from the established models. It had to be a volcanic caldera lake or fed directly by a magma chamber. And the geology of that area just doesn't support it.
So the river had to be pure myth.
But this is where the story pivots. It all comes down to local knowledge.
Yes, it was Russo's aunt. She wasn't a scientist, but she lived near the area, and she just insisted, no, it's real, I've been there.
She'd actually been to the river.
She had, near a healing center called Mayantuyacu. She became this unlikely guide that just bypassed all the scientific skepticism. Russo, trusting his family over his colleagues, he followed her deep into the Huánuco region.
And there it was.
And there it was, steaming and deadly, undeniably real. That moment, that collision between the certainty of scientific theory and the undeniable physical reality. That's what launched him on his decade-long quest.
And he must have quickly realized his aunt's story of swimming in it. That must have been in a cooler part.
Oh, absolutely.
Yeah.
The main body of water was lethal. So his goal shifted. It went from just confirming it exists to understanding the specific, rare, elegant mechanism that lets this impossible geological marvel operate.
Which is where it gets really interesting. Because if it exists and there's no volcano, then the physics has to be unique. It has to be a 1 in a million confluence of factors.
Okay, before we get into the how, let's just reinforce the scale of this thing, because this isn't just a few hot springs feeding into a little trickle.
No, this is a large-scale, continuous river system. The total length is around 9 kilometers, but the continuous hot section, the part we're talking about, spans an incredible 6.2 kilometers.
6.2 kilometers.
To sustain a near-boiling temperature over that distance is what makes it globally unique.
And it's a big river, not just long. It's a substantial body of water. In some spots, it could be up to 25 meters wide and 4.5 meters deep. We're talking about a massive amount of thermal energy being pumped into a river that wide and that deep constantly.
So when Russo started his detective work, he had to rule things out. We know he ruled out volcanic heat because of the distance. What was next?
The second hypothesis was industrial pollution.
Which is a critical step, right? Especially in a region with resource extraction. You see thermal anomalies from leaky oil or gas wells.
Exactly. But the water chemistry analysis gave the definitive answer. Russo's team took careful measurements of mineral content, conductivity.
Yeah.
If the heat were from oil and gas, the water would carry distinct chemical signatures, hydrocarbons, specific contaminants. Instead, the chemistry pointed overwhelmingly toward a natural, deep earth origin.
What was that signature specifically? What does it look like?
Well, the water was high in certain minerals and salts that you typically find leached out of deep sedimentary rock under high heat and pressure. But it didn't have the high chloride or sulfur content you'd expect from a shallow magmatic system.
Okay.
And most importantly, it confirmed the water was meteoric.
Meaning it started as rainwater?
It started as rainwater, but it had circulated deep underground for a long time before coming back up. And this established the final hypothesis as the truth. This is a unique, natural, fault-fed hydrothermal system. It's powered purely by the Earth's natural internal warmth.
Okay, that is the complex truth we need to break down. How does the Earth's natural warmth, not a volcano, generate enough power to boil a river for 6 kilometers.
You have to visualize a kind of hidden plumbing system beneath the Amazon. It starts with the fuel, the massive amount of rain you get in that environment.
Okay, step one, a tropical storm hits, rain falls.
Correct. Step two, instead of just running off, this rainwater finds pathways to infiltrate the ground. And here's the crucial factor. There are massive, deep-reaching faults and fractures in the bedrock.
So they're like structural weak points.
Exactly. They act like open, high-speed plumbing lines going down.
So the water finds these channels and is diverted not just a few feet, but kilometers deep into the Earth's crust.
Precisely. And this is where we meet the geothermal gradient. It's a fundamental law of geology. The temperature increases naturally the deeper you go into the Earth.
How much hotter are we talking?
It's roughly 25 to 30 degrees Celsius hotter for every kilometer of depth. So if that rainwater sinks 3 or 4 kilometers down, it gets subjected to immense natural heating.
And this isn't volatile magma heat.
No, this is the steady, continuous, quiet baseline warmth of the Earth itself, acting on a huge volume of water trapped under pressure. This process is happening over decades, maybe centuries of circulation.
But if it sinks down so far away, what pushes it back up right at the riverbed? Why doesn't it just stay trapped? That seems like the rarest part of the puzzle.
That's the return mechanism, step 4. The very same faults that channeled the water down also provide the pathway back up. Because the water is heated, it expands, it becomes buoyant. And you combine that with the intense pressure from the deep rock and the continuous recharge of cold rainwater pushing down from above.
It forces the hot water up. It's like a geological convection engine.
That's a perfect way to put it. The Shanay-Tempishka just happens to flow directly over a perfect alignment of these ascending fault lines.
That's the extremely rare geological accident. The superheated water surfaces as countless hot springs, vents pouring directly into the riverbed.
And because the system is so robust and the recharge of rainwater is so consistent, it maintains that flow and that temperature over 6 kilometers. A continuously boiling river, powered not by a violent volcano, but by deep circulating rainwater heated by the Earth's steady internal furnace.
It just changes your whole perspective. It's less about a single localized volcano and more about these huge, silent, global forces creating an opportunity. The scale of that deep circulation system must be staggering.
It is. The flow rate and conductivity confirmed it. It's a stunning example of how hydrogeology and tectonics can align to create something that seems to defy logic, even when it's perfectly explained by physics. So now that we get the mechanism, we have to confront the consequences of that temperature. This is where we move from elegant physics to immediate visceral danger.
The river is beautiful, it's steaming, and it is lethal. Let's go back to those lethal dynamics because the contrast is so shocking. A river is supposed to give life. This one is an instant ecological barrier.
The danger is extreme. The water is up to 95 degrees Celsius. To put that in human terms, the temperature that causes severe tissue damage, third-degree burns, what we call cooking, starts around 70 degrees Celsius.
And at 90 degrees.
The process is instantaneous.
Russo and the local community, they've provided these haunting descriptions of what happens when small creatures like a frog or a small rodent fall into the hottest parts.
The reports are.
Yeah, that hurt.
They're clear and they're disturbing. The trauma is immediate. Small animals might struggle, but their muscles essentially cook before they can get out. The protein structure in the body just denatures so rapidly.
The specific observation that always stuck with me was the effect on the eyes, how they rapidly turn opaque and cloudy when they hit the near boiling water, an instant sign of irreversible damage.
Yeah, and the air itself is aggressive. That thick steam, it stings your nose and lungs just breathing near the hottest sections. It is the ultimate ecological filter. Most vertebrates cannot survive this. But this ecological pressure cooker presents an incredible scientific opportunity, an ecosystem of extremes.
Life always finds a way, even here. The boiling river is a living laboratory for extremophiles.
Absolutely. Russo's work with geneticists revealed this thriving, invisible ecosystem that cataloged bacteria and archaea microbes that have not just adapted to survive, but to flourish in these conditions.
And what's the big deal about finding these organisms here? What are we looking for?
We're looking for novel biochemistry, specialized enzymes. Standard enzymes in our bodies would denature, they'd unravel instantly at 90 degrees Celsius. But these extremophiles possess unique, thermostable enzymes.
Meaning they're stable at high temperatures.
Exactly. For example, some archaea produce extremely hardy polymerases.
Polymerases, that's the machinery for DNA replication.
Yes. And the ability to replicate DNA at high temperatures is crucial for things like PCR, the polymerase chain reaction, which is fundamental to modern biology, forensics, medicine. So if we find novel super hardy enzymes here, they could potentially revolutionize biotech.
Hmm.
The river is basically offering us a toolkit of super resilient proteins.
So while the macro life is killed instantly, the micro life is thriving and has huge potential value.
Exactly. The life and death divide is stark, and you see that reflected in the bigger ecosystem. Fish are completely absent from the 90-degree main channel.
But the river is long, and it must cool down eventually.
It does. As it flows, it mixes with cooler groundwater and small tributaries, and it loses heat to the air. Studies have shown that fish communities gradually return as the temperature drops to a safe level. It shows how finely tuned the local aquatic life is.
That transition point where it goes from lethal to life-supporting must be fascinating. And it highlights that deep, localized knowledge we talked about. The local communities, they know exactly where that line is.
They practice a very careful and essential coexistence. They treat the source with reverence and caution. But the cooler margins and the areas downstream, those are integrated into their daily life.
You said they treat it like a giant, continuously heated utility. What does that actually look like?
Well, they use the river margins, where the temperature might be like extremely hot tap water, say 50 or 60 degrees Celsius,
Okay.
for cooking, for safely steaming or boiling food. They also use it for washing clothes, for bathing. It minimizes the need for fire or other fuel sources.
That's an incredible mastery of the environment. A casual visitor would only see the danger, but the local communities understand the subtle flows and temperature gradients needed to harness this natural powerhouse safely.
It's a perfect example of traditional ecological knowledge providing a way to live alongside something that would otherwise be completely insurmountable.
So we've covered the myth, we've nailed the physics, and we've looked at the unique life and death dynamics. But now we have to turn to the final, most immediate issue: conservation. It's such an irony that Russo's research confirmed this impossible wonder, only to find that the biggest threat to it isn't its own heat, it's us.
That realization forced a huge change in Russo's work. He started as a pure geoscientist, just mapping fault lines. But the urgency of the threats on the ground turned him into an advocate. His mission shifted from explaining the physics to protecting the plumbing.
And if the whole river depends on clean rainwater seeping through the forest, then destroying that forest is like cutting the fuel line to the engine.
Exactly. The entire delicate system is threatened. We can break it down into three primary threats facing the Shanay-Tempishka, starting with the biggest one: deforestation.
The sources cite some really alarming figures on that.
The area has been subjected to extensive logging, slash-and-burn agriculture, clearing for cattle pasture. At times, the rate of clearing was reported as the equivalent of half a soccer field a minute.
A minute, that's catastrophic. Why specifically does that threaten the geothermal system?
When you remove the forest canopy, you change everything on the ground. The deep root systems that manage water absorption are gone. You get more surface runoff, massive erosion, the soil chemistry changes.
And the water that does get down to the faults is dirtier.
It's siltier, less clean. It could potentially clog the system. And if the recharge rate of water changes too drastically, the pressure that forces the hot water back up could drop, destabilizing the whole thermal anomaly.
So the system relies on the biological integrity of the rainforest to maintain its geological integrity.
A perfect ecological feedback loop. Now, threat number two is the shadow of industrial expansion, specifically oil and gas exploration.
Right. The Amazon basin is a prime location for that. What are the specific risks here?
The region around the river is inside designated oil and gas concessions. That brings road building, which opens up the jungle. It brings the risk of pollution from spills. And most critically, it brings the risk of structural damage from drilling and seismic surveys.
You're talking about accidentally ruining that natural plumbing system we just spent all this time explaining.
Precisely. Remember those deep fault lines that act as channels. If a deep drilling operation intersects or compromises those specific localized faults, the highly pressurized hydrothermal system could be irreversibly altered.
You could just turn it off.
You could turn it off. The water might reroute, the pressure could drop. A unique natural wonder destroyed not by a volcano, but by an accidental drill bit. It would be a tragedy.
And the third threat is, well, it's a consequence of its own fame, isn't it? Unregulated tourism.
It's the double-edged sword of discovery. Russo's work, his TED Talks, they made the river famous. Now everyone wants to see the impossible. But without any infrastructure or regulation, that leads to immediate degradation. Litter, trampling sensitive banks, erosion.
and disrespect for its cultural value. To the local communities, this is a powerful spiritual entity, not just a tourist attraction.
So the solution had to be collaborative. Russo realized he had to work directly with local leaders, including the respected Shipibo healer, Maestro Juan Flores, who acts as the spiritual guardian of the area.
So how does that collaboration blend the science and the spiritual tradition?
It pushes for legal protection, but under the leadership of the local communities. They're framing the fight not just around scientific rarity, but around cultural heritage and spiritual preservation. Maestro Flores' traditional knowledge informs the best practices for managing the land, while Russo's data provides the scientific backing for legal appeals.
A fusion of the scientist providing the mechanism of destruction and the spiritual leader providing the map for coexistence?
The goal is a community-driven management system that can resist those external pressures while allowing for respectful visitation. Protecting the Shanay Tempishka means protecting the entire ecosystem around it. It's a defense of a system powered by something as simple as falling rainwater, transformed into an irreplaceable anomaly by the silent mechanics of our planet.
This deep dive has spanned centuries of tradition and kilometers of physics. We started with these terrifying cinematic legends, the gold-seeking conquistadors and the majestic serpent spirit, Yakumama. We followed that path right through the intense scientific skepticism that denied it could even exist, and we landed firmly on the hard yet beautiful physics of the Earth's quiet internal warmth.
The Shanay Tempishka is a stunning realization. It's both less magical, free from gold curses or volcano sorcery, and yet far more profound. It's a rare, stable, persistent, natural marvel. A stunning expression of the geothermal gradient.
It's a place where, as we've seen, localized indigenous knowledge was centuries ahead of Western science. But that modern scientific understanding, once we got it, revealed just how fragile the system is in the face of modern development.
And this brings us to a final provocative thought for you to consider. If one of the largest and hottest thermal rivers on Earth, sustained by something as fundamental as falling rainwater interacting with the basic internal heat of our planet, can remain hidden from global science for so long,
And then be immediately threatened by logging and industry in this era of hyperinformation.
then what other truly impossible wonders, what other globally unique ecological or geological phenomena might we be failing to discover, to map, and to protect right now, until the pressures of development and unmanaged fame extinguish them forever?
The efforts led by Maestro Flores and Andres Russo show that the way forward is to harmonize that traditional reverence with the rigorous demands of scientific conservation. That balance might just be the only way we have to preserve the planet's rarest secrets.
That's it for this episode of Brain Binge. If you enjoyed getting your mind twisted tonight, do me a favor, comment, like, and subscribe so you don't miss the next deep dive. Got a weird fact, mystery, or place you want an episode about? Drop it in the comments. I read as many as I can, and I'm always hunting for new ideas. Thanks for listening, and thanks for letting your brain binge with me for a while. Stay well, stay curious, and I'll see you in the next one.